Right, ladies and gentlemen, welcome to the first voyage of the land yacht. As we can see from our JLD meters here, we're currently running on the front battery box, which is giving us about 32.5 volts for our first round of shakedown tests. Today was the first day of actually driving the car under electric power, and this is my second time doing this. I think I'm going to be doing this for a long time. So anyway, we're going to reverse down the length of the driveway and we're going to try some tricks. So here we go. Reverse gear, brakes off, giving her some juice, and we're rolling. I'm going out to drive now. I'm going to take out the neighbour's trees. This thing is a bit bigger than what I'd usually be driving. So, fifth gear. Here we go. That 13-inch doesn't even feel that. 150 amps. Just flies up the driveway. Begin to think the gearbox might have been a little bit superfluous. Maybe I'm wrong about that. Anyway, let's see what's next on the agenda. Okay, let's see what we got here now. Let's reverse back a bit. Oops, there goes the carb. Third gear. Oh, we got third, yeah. Oh, we're going backwards. No, we're not. There we go. That's one thing about the huge tires on this. Carbs just aren't a problem. There's just oodles of torque in this motor. It just doesn't, this is only 32 volts here. I mean, fifth gear, 300 amps of a burst, and we're rolling. I mean, this car is not light, I can absolutely guarantee you that. Trust me, I've jacked it up. I know how big and heavy this car is. I've jacked it up multiple times on multiple ends. Fifth gear again. Just effortless. And we can just stay in fifth here. Swing back into the drive. Come on, land yacht. Well, that's interesting. Because I know for a fact in the 3 series, you can take off in fifth, certainly. But it's nowhere near the responsiveness of this thing. So I think that motor is definitely a good choice. Now, let me see if I can undo the duct tape here because I just want to explain a couple of things here just on the dash very quickly. Come on, duct tape. Ooh, there we go. Now, let's get rid of the duct tape for a second. Now, what I'm hoping we're going to be able to see here, and I'll try not to Blair Witch this, but that is our first EV mile on this car. If you can see there just in the mileometer here, 1.0. It's our first mile that this car has travelled in its history of 175,574 miles, that the car can actually say that it's travelled under electric power. Now, so that's first very good thing. Now, we might notice there that our tachometer is telling us that we're at 500 RPM. That is our Arduino feeding the tach pulses so that the ECU believes the engine is running. We haven't set up the tach sensor on the actual motor as yet. That's just me opening the window, which needs a bit of lubrication by the sounds of it. Now, as I say, so that's the tach sensor I'll be fitting. So I'll show you that in a few minutes. Something else I just want to do quickly here. If I turn the car off. Now, one of the things about any car in this country is that it must pass a annual inspection. It's called the NCT, National Car Test. Now, one of the things that is checked in that, believe it or not, part of the emissions systems obviously are checked, but we can pretty much circumvent a lot of that. But any of the safety systems in the car, it's very important that they operate, and that is the main reason that I've kept the DME and its associated wiring in the car, in order to keep the ASC, which is the active stability control, and ABS functions operating. Now, I'm going to turn the key on and I'm going to start the car. Now, what we'll see here in this area here and here, we'll see two lights illuminate briefly and then go back out. One will say EML, and the other is a little kind of a skid symbol. I think it's either the one up there or down here, and it basically means that the ASC system is functioning. So I'm going to go ahead now and start the car. So you'll see those two come on and then go back out. We do have a general check engine light still illuminated, so that's another thing that I have to deal with. But the most important ones being the EML and the ASC system. And if I cycle the ASC button here, we can see that the little skid symbol goes on and off there to tell us that that's functioning properly. Other things inside the car that we've seen would be the two JLD meters. Now, I decided to fit two of them because of the fact that I actually happen to have two of them. This is the JLD 404 amp hour meter. It's the one that's commonly been demonstrated on EVTV and by other people with their conversions. And on the left of that you'll see another JLD 404, but this one is a power meter. So this means that I can have dual displays, amps, and if I wish to have volts here, or I can have power in watts and kilowatts. I can have relays that I can use to control things based upon programmable inputs and so forth. This one I'm having a little bit of problems getting this to read current properly, so I'm just going to pull that back out. I might have connected a wire incorrectly on that, so I'm going to pop that out and see what's going on there. And we have our RS232 cable here for the controller, so I've got to make a little plate to go in there to blank off all that and to make that into a neater setup. It's just here today so we can get our roll on the car. In here then we have our little DC to DC converter, 12 volts in, 12 volts out for the JLD meters, and stereo, and that's about it for the dash so far. So we'll have a look under the bonnet and run through some of that stuff now as well. Okay, so what we have is a very basic setup with the front battery box. As we can see, we have 10 of the CA180 FI cells in that box, strapped up with some temporary cables set up and to supply us with our traction power. Now, the most negative terminal here connects to the 500 amp shunt. That's a 75 millivolt 500 amp shunt. It's one I got from Jack, and that one I had a friend of mine that's good with modeling make a little epoxy mold for that, as I wouldn't be any good at that kind of thing. So with our 10 cells, cable then comes back to a 400 amp NH2 fuse that for the minute, just for the testing phase, will be satisfactory. I had this in stock. This is a fuse that I use in the 3 series with the 500 amp controller. Never had a problem with that. And some people expressed concern when I was filming that fuse actually previously that it was an AC fuse. It's rated at 500 volts AC, but if you check the data sheet, you will find that it's also rated to 250 volts DC at, I believe, 12 kA, so that should be satisfactory for this job. Now, across the center plate here we have some relays and fuses and terminal blocks, and they're all mounted on a DIN rail that's screwed down to the 10mm aluminium plate. Now, the wiring is a little bit haphazard at the minute because I've been just chopping and changing stuff, but I'm going to have some nice trunking going along here which will tidy up all of this stuff. But just to give a rough outline of what's actually here, we have the fuse here. This is a 0.5 amp 10 by 38 fuse, which fuses the traction voltage that is supplied into the JLD meters inside for the purposes of monitoring traction voltage. Beside that, we have another 10 by 38 fuse holder. It has a 10 square cable feeding it from the controller side of the main contactor, which is inside the controller. You'll see that blue cable comes out and around with the traction cables here. So this will be to supply HV power for things like heaters, aircon pumps, all that sort of thing. Here we have a little timer relay, a little 12 volt timer relay, and the purpose of that guy at the minute is to introduce a little bit of hysteresis into my brake pump, because the vacuum sensor that I got for this is just an industrial vacuum sensor, and it unfortunately has no hysteresis in it at all, so the pump was just basically cycling on and off continuously. But this little timer puts maybe a 4 or 5 second delay into that, and it basically calms the whole thing down so the pump doesn't continuously cycle. I may end up changing that switch, so that may be obsolete. Here in the center We have a 12 volt 8 pin 2-pole changeover relay. This supplies power to the controller and to what I call the instrumentation power bus, which is basically a 12 volt feed to the Arduino up in the DME box up there, and to do the DC to DC inside the cabin for the JLD meters. To the right of that one we have the ignition relay. This basically latches on when it gets a start signal. So it means that you actually have to turn the key to the start position before any of the power buses will come up. The reason for my doing that with this particular car is that it has the EWS security module in it, so it just adds a little extra layer of security to the car. To the right then we have two more 10x38 fuse holders. One of them is currently active and supplies a 16 amp fuse for the brake pump. To the right of that we have three 20mm fuse holders. They have fuses in those for the basically the ignition 12 volt positive, the controller 12 volt supply, and the instrumentation bus 12 volt supply. Got some big terminal blocks here just for breaking up the unswitched 12 volt feed, which comes up from as a terminal down there. Probably can't really see it, but it's just down behind the power steering pump, and I've ran a 16 square cable down to that to pick up unswitched 12 volts. That would normally have supplied power to the starter and alternator for the combustion engine. So back down here then to the right we have a relay for the brake pump. Some of these wires out of the way. This is a 30 amp 12 volt relay for the brake pump. Here we have a terminal strip screwed straight down to the aluminium for 12 volt ground. There's a large maxi, I believe they're calling maxi fuse. This particular one is a 50 amp maxi fuse. It's a big blade fuse for the power steering pump, and there's a 70 amp 12 volt relay that controls the power steering pump. Finally here then on the plate we have the throttle body. It's just basically bolted down. It's just not doing anything at the minute apart from responding to the ECU commands. So that's about the plate. Here obviously we have a lot of wiring that needs to be sorted out. Some of these signals will be used and some of them will be redundant. In fact, a lot of them will be redundant. So up on the controller we have our famous 23 pin amp seal plug. I had absolutely no problems at all crimping the pins on that plug with just a little standard pliers. Just took a little bit of practice, but there's 10 connections there and no problems at all. Once I got the hang of that plug, I actually it would begin to win me over a little bit. So obviously then we've a 10 core screened cable that goes back inside the ECU. I call it the tank in here. So I'll just put the camera down and I'll go ahead and I'll just take off the cover from the ECU tank, and we'll be able to see then what basically goes on in here. Nothing terribly exciting, but seeing as we're here filming, we might as well cover it. Yeah. So a little bit of disassembling to do here. It's just some shields and splash guards and stuff like that. But the actual ECU tank itself is quite good. So let's have a look, see in here now. So in here we've got ourselves a real maze of wire, but it's not actually that complicated. In the case here we should also be able to see the little Arduino board. I've just got a temporarily cable tied in there. I'm not feeding it an tacho signal at the minute, it's just hard coded to 750 RPM, and it's feeding that back into the ECU crankshaft position pin. Seems to be quite happy doing that. Ultimately we'll have our tach sensor screwed in there and be sending a signal back up to the Arduino, which will be converting that into our 60-2 signal to give us actual motor RPM on the dash. So in here then we have two more 10-core cables. One of these, this particular one here, is the harness that comes in from the amp seal. Some of the cores are connected, some of them are not. Here for example we have 3 unconnected cores from that. One of them is a 5 volts output, which we don't need, but I just thought I'd bring it out anyway. And one of them is a brake input, which is the green, and the blue is the tachometer input. So I have some more signals to tap into here in our DME. This other wiring bundle here, this goes back into the car to provide us with our RS232. So we just splice those together there for feeding RS232 into the cabin, and it gives me all of these spare cores here for whatever I may decide to do in the future: switches, charging indicators, J1772 signals, all that kind of thing. So that gives me all of that freedom there. So that is about the size of where things are with the land yacht at the minute. We've got a lot of work to do, but just having the car mobile means a hell of a lot to me at this stage. It just it kind of unblocks the dam, for want of a better word, and means that I can proceed with the rest of the project. So yeah, that's about it. I'm not gonna, I've blabbered on too much probably already, so we'll see how we get on with the next part of the project, which is gonna more than probably center around the charger. So we'll be having a look at that. That's going to be I'm going for a very high power charger for this car. These cells can certainly take it. A lot of the infrastructure being installed in this country now can supply that power. So we're going to do what we need to do to make sure that that we can actually take advantage of it. So this is it, guys. This is the car. It needs a wash. It's been sitting in my drive for 7 months. So once we get a few more cells connected in, get some paperwork done, can actually take it to the car wash. So that'll be another experience. I never forget the first time that I took that one to the car wash. I was well, let's just say I needed a wash afterwards. So yeah, that one also needs a wash. It's covered in bird droppings. So gotta love it. Got two EVs, and I've probably got enough room in this driveway for, well, I reckon at a pinch I'd probably get 4 of them in here. So No shortage of space, just need to get some time now to finish this baby off and give her, as I say, give her the charger that she deserves. And yeah, that's about it. Talk to you soon. One more thing. This just doesn't get old. 5th gear. 30 volts, 190 volts. This is going to be an interesting project. Stay with us.